Hey, welcome. Have you ever really stopped to wonder what's going on inside your phone or your computer? We always talk about them having a brain, right? But it turns out it's not just one brain. It's more like a whole team of specialized brains all working together. Today, we're going to pull back the curtain and meet this whole family of processors, from the humble jack of all trades all the way to a quantum mind bender.
You know, our whole story starts in a place you probably wouldn't expect, deep inside the Earth. The journey from a simple mineral, just a rock, really, quartz, to these impossibly complex chips that power our entire world, it honestly feels like a kind of modern-day alchemy. It's this whole process of purifying, cooking, and etching these microscopic patterns that can somehow channel lightning. It's just wild. So yeah, that's the big question, isn't it? How on earth do we get from a plain old rock to a device that can run Windows, render an entire video game world, or even train an artificial intelligence? Well, that's exactly what we're here to unpack. We're going to dig into the different ways computers actually compute things, right down at the hardware level. All right, before we meet the modern team of processors, we got to take a super quick trip back in time. To really get where we're going, you first have to understand the incredible journey of how we even got here. And man, what a wild ride it's been. The very first programmable computer back in '36, it was a mechanical beast. We're talking 20,000 parts and a clock speed of 1 hertz. That's 1 instruction per second. Then, a few key breakthroughs just changed everything. The von Neumann architecture gave us the blueprint for all modern computers. The transistor gave us the tiny electronic switch we needed. And finally, in 1971, Intel managed to cram it all onto a single microprocessor. We went from 1 instruction per second to literally billions in just a few decades. The speed up is just staggering.
So let's start with the one you've definitely heard of, the CPU. This is the original brain, the commander-in-chief, the big boss inside your computer.
The Central Processing Unit, or CPU, is the ultimate generalist. It's the thing running your operating system, launching your apps, and basically making sure all the different parts of your computer are talking to each other. Its real superpower, though, is handling sequential tasks, problems that have a ton of complex if-this-then-that kind of logic, things that have to be figured out one precise step at a time. Think of it like a master chef, meticulously following a very complicated recipe.
And that seems like the obvious next step, right? If 1 core is good, then 100 cores must be better. But, it's just not that simple. Adding more CPU cores gets really expensive, it generates a ton of heat, and it just eats up power. You hit a wall pretty fast where you're not getting much more performance for all that extra cost and energy. The world needed a totally different approach.
And that different approach led to the rise of our very first specialist, the GPU. It was basically born from the need to solve a very specific kind of problem that the good old CPU just wasn't built for.
Okay, just look at this for a second. The scale here is absolutely bonkers. A really high-end CPU might have, a couple dozen cores? A high-end GPU can have almost 10,000. But, and this is the crucial part, they are not the same kind of core. What a GPU does is it trades a few really complex, powerful cores for thousands and thousands of simpler ones. Each one is like a tiny math specialist, all working together as part of one massive team.
See, a GPU is an absolute master of parallel computing. It's designed to do thousands of pretty simple math calculations all at the exact same time. This is absolutely perfect for rendering the millions of pixels on your screen in a video game, or for the huge math problems needed to train AI models. And that is exactly why they've become so incredibly important.
This analogy just illustrates the difference perfectly. A CPU is like a Toyota Camry. It's incredibly versatile. It can take you to work, it can go to the grocery store, you can take it on a road trip. A GPU, on the other hand, is a rocket ship. It is unbelievably, mind-blowingly fast at one thing, going in a straight line. You would never use it to pick up groceries. But if you need to get to the moon, well, it's the only tool for the job.
But the story doesn't end there. As the demand for things like AI and these massive data centers just exploded, even the specialized GPU wasn't quite efficient enough for some tasks. This led to a whole new wave of what you could call hyper-specialists.
So, say hello to the TPU and the DPU. Google's Tensor Processing Unit, the TPU, is purpose-built just for AI. It strips away everything that isn't needed for those massive multiplication problems at the heart of deep learning. Then you have the Data Processing Unit, the DPU. This is like the unsung hero of the data center. It's designed to do one thing really, really well, move data around. It takes all the networking and storage jobs off the CPU's plate, freeing it up to do the complex thinking it's best at.
So here it is. Here's our whole team lineup. The CPU is your generalist manager. The GPU is the parallel math genius. The TPU is the hyper-focused AI accelerator. And the DPU is the logistics expert, basically directing all the data traffic. Each one has its own distinct role, and they all work together to get the best possible performance.
Now, so far, all of these processors, from the generalist CPU to the hyper-specialist DPU, they're all playing by the same basic rules, the rules of ones and zeros. But our final processor, the QPU, it doesn't just specialize in a new task. No, it completely rewrites the fundamental rulebook of computing itself.
Okay, so classical computers work with bits, which can be either a 0 or a 1. Simple, right? Well, quantum processing units, or QPUs, use something called qubits. And thanks to this wild quantum property called superposition, a qubit can be a 0 and a 1 at the exact same time. This means it can represent and explore all the possible solutions to a problem at once, unlocking this exponential leap in computing power that classical computers can only dream about. It's truly mind-bending stuff.
So what's the big deal? Why does this matter so much? Well, this new kind of power, it comes with new kinds of challenges. The algorithms that keep our entire digital world secure, they rely on math problems that are practically impossible for today's computers to solve. But a powerful quantum computer could run algorithms that would crack these problems with ease. It would be like trying every single possible key at once. This poses a massive, massive threat to the encryption that protects everything from our bank accounts to national secrets. So we started with a single generalist CPU, and from there, we've evolved this whole team of specialists, each one designed to solve a really specific, really complex problem. And it leaves us with this one fascinating final thought. As our challenges in AI and science and data just continue to grow, what entirely new problems are going to force us to invent the next generation of processing units? What will the PU of tomorrow even look like? Thanks for joining me.